Today's lesson is about calculating angle measures and segment lengths inside circles. First off, we need to talk about what a secant is. A secant is a line that intersects a circle at 2 points. So go ahead and copy down the definition on your notes and add a quick picture of a secant. A quick note, a secant is different from a chord in that a chord is not a line, it is a line segment. A chord would start and stop on the edges of the circle and not continue past the outside. That's really the only difference between a chord and a secant. A secant is also a little bit like a tangent in that it is a line that has to do with circles. The difference from a tangent is that tangents brush by the edge of the circle and only touch the circle at one point. A secant goes through the circle to some degree and touches the edges of the circle at 2 points. Now go to your postulate paper and find theorem 12-13. The measure of an angle formed by two lines that intersect inside a circle is always going to be half the sum of the intercepted arcs. In other words, if you want to calculate the measure of an angle found between two lines that intersect inside your circle, like this angle x, you just average out the measure of the arcs that's between. I want you to notice that this is really useful whenever your angle is not a central angle. If this had been centered a little bit differently at the center of the circle, then we could have just looked at the arc above it and said, oh, central angle and the arc it intercepts are always the same. But this is not a central angle, it's off center. So instead of matching the 100 degrees here, it's actually the average of the 60 and the 100 degrees it's between. It doesn't really matter which one you put first, the 60 degrees or the 100 degrees. Just average them out, 80 degrees. Next, you're going to go back to your notes worksheet, and on the front page of the notes, there are 3 problems that you can use this theorem to solve. They're all mixed up. Hunt down the 3 out of the 6 problems you can use theorem 12-13 to solve, and try it. Pause until you're done. All right, so if you found 1A, 2A, and 3B, excellent work. Those are the 3 where you have lines that are intercepting inside the circle. In other words, the rule you just learned, the theorem you just learned, works anytime it looks kind of like an X-Men symbol. Go ahead and check your answers. For 1A, you should get 93 degrees. For X, you should get 126. For 2A, and then 3B, you should get 112.5 degrees. A quick note, 3B asks you not only to solve for X, the angle that's between the 85 and 140 degree arcs, but also for Y. You don't know what arcs Y is between, however, you know it's a linear pair with the angle X is in. So you could solve for Y that way. Now go back to your postulate paper and find theorem 12-14. This is going to help you with the other 3 problems on the front page of the notes. Sometimes your lines do not intersect inside the circle. Sometimes your lines intersect outside the circle. When that happens, you're going to see there's a similarity to the old rule, just one small difference. Whenever the measure of an angle formed by 2 lines that intersect outside a circle is half the difference of the intercepted arcs. So your intercepted arcs are still what you use, the 80 and 200 here. The difference, though, tells you to subtract. So really the only thing that changed in your formula is that instead of adding your arcs and dividing by 2, you are subtracting your arcs and dividing by 2. And a key rule, always do the larger arc minus the smaller arc with these problems. So you do 200 minus 80, take that answer and divide by 2, you'd get that angle X here is 60 degrees. Pause here and try the 3 remaining problems on the front page. There's a really good challenge problem that's actually near the top of the page, 1B. So you might actually want to save 1B for last. All right, when checking your answers for these last 3 problems on the front page, we're going out of order, starting with the easiest first. So find 3A and check your answer for X and for Y. So the thing is, at first, it's impossible to solve for Y here because you need to know the outside arc here to subtract when you do arc minus arc all over 2. We need to figure out what x is to be able to solve for y. Now, you could use that rule that if you add up the measures of all the angles, or all the arcs around your circle, it should always equal 360. So you could say x plus 95 plus 72 equals 360. Once you know what x is, then you could do arc minus arc all over 2 to get y. You could use a similar process to solve 2b. So you could say, well, if this whole circle is 360, I could just subtract 110 and get the whole rest of the circle has a measure of 250 degrees. And that's my outside arc. I could do arc minus arc all over 2. Y equals 70. 1b is the challenge problem. I want you to notice that this time they are telling you what the angle, the measure of the angle where the two lines intersect is. Normally, that's where your variable is. So essentially, they're telling you that answer to angle equals arc minus arc over 2. So your starting formula should actually look like this. When you're doing arc, larger arc minus smaller arc, it should be 98 minus y all over 2, and then equals an answer of 22. Then you could circle y and work to isolate it. You can multiply both sides by 2 to cancel out the over 2. You can minus 98 from both sides to cancel that out. You could divide both sides by negative 1 to get y completely by itself. Y equals 54 degrees. Now go back to your postulate paper. So at this point, you know the theorems you need for solving for angles where two lines intersect inside of your triangle, or circle. Next, we need to talk about how to calculate the lengths of segments of chords and secants inside your circle. Here's the first rule. The product of chord segments are equal. Remember, product means multiplication answer. So what they're saying is if you have two chords that are crossing inside a circle, the segments of each chord, when your chords are split into pieces where they intersect, multiply together to get the same answer. They have equal products. So you could say 5 times x equals 3 times 10, and solve from there. Pause here and see if you could figure out how to use this rule to solve question number 4a and b. Go ahead and check your answers. And now go back to your postulate paper. Find theorem 1215 case 2. The products of secants and their outer segments are equal. A good way to summarize what this rule is saying in a way that's easy to memorize is outside segment times whole secant. If you remember that, what they're really saying is if you take this outside segment and you multiply it, or find the product of that outside segment and the length of the whole secant, it's actually going to equal outside times the whole secant of the other line or secant as well. So here the outside would be 3. The whole combo would be x plus 3. Multiply those together. For that second one, the outside is 5. The whole combo would be, when you add up 5 and 10, 15. Pause here and see if you could figure out question number 5, A and B. Don't do number 6 yet. Pause after number 5. Go ahead and check your answer on 5a. Outside 4 times whole thing, y plus 4, equals outside 5 times whole thing, 12. B is using the same rule, but I want to point out the simplifying is where people tend to make small errors. So if you set it up like this initially, excellent work. I just want to point out, when you're doing outside times whole thing for this top line segment here, the whole thing, z plus z, is really 2z. So outside times whole is z times 2z. And then z times 2z, don't forget, that would be 2z squared when you multiply the z's together. And then you would divide both sides by 2 and square root. So you could write your answer as either 3 squared to 2 or 4.2 if you wrote the decimal version, because I didn't remember to specify how to write your answer. It works either way. Now go back to your postulate paper and find the next case for this theorem. This is actually, you could really, if you memorize that rule for the previous case when you have lines intersecting to make a V outside your circle, outside segment times whole secant is still going to be useful. Except now, this one isn't quite a secant because it doesn't go inside the circle. It's a tangent line because it just brushes the side. But the pattern still holds, in that you could think of it as outside times whole thing. The outside segment is x because it never goes inside the circle. That whole thing is the outside segment. But the whole length of the segment is also x. When you do outside times whole, it's x times x. And that will equal outside times whole for the other line segment. And you could square root to solve. Pause here and try the entire rest of the page. A quick note I want to make about 6a is this. You're doing outside times whole thing, 10 times 10 for one side of your equation, y times y plus 21 for the other. I want you to notice that this is one of those rare cases where you're distributing a y into the parentheses here and you end up with a y squared. Quick reminder, if you have an equation that has both variable squared and variable to the power of 1, you probably want to first try factoring to solve. To solve by factoring, you need 0 on one side of your equation, so you could subtract 100 from both sides just to get 0 on the left side of your equal sign. And then you could think to yourself what numbers multiply to 100, but add or subtract to get 21. And if you thought of 25 and 4, well done, because 25 times negative 4 would get you negative 100 when you FOILed, but 25 minus 4 would get you 21 in the middle. Now, keep in mind, if you have a factored version of this, one of those factors has to equal 0 if multiplying them together gets an answer of 0. So you could think, well, if y plus 25 equals 0, then y equals negative 25. If y minus 4 equals 0, then y equals 4. Now, if our original equation had just been this top row and there was no picture associated with, both of these would have been our answers. But because our problem started as a diagram, we have to look at the diagram and see if those answers actually make sense. Oh, negative 25 units long. Nope, negative doesn't make sense where y is here. So cross out y equals negative 25 out of our two answers. The only one makes sense on the diagram is y equals 4. Go ahead and check your answer on part B as well. Now check your answer on 7. I'm not too picky about your format for answers. For example, for this one, if you left it as x equals 131 over 12, excellent work, that's fine. Or for this one, if you wrote roughly 9.5, that's fine too, if you square rooted it in your calculator. Great job, everybody. Don't forget to turn in a picture of your notes on Schoology when you're done.